This video will cover the review for exam 2, and we're going to start from problem number 6. That's where we left off on our first video. So the question here is to determine if those fractions are equivalent. So we're going to start here with problem 6. And so 7/9, I can tell you right away that they are not, but let's see why not. If we had to compare which one was bigger, I would probably say that one, because this fraction is divided into more pieces, therefore every piece is smaller. And here, to complete one whole, we're only 2 pieces away, right? But those pieces are small. Now from here, to complete 9/9, which will equal to 1, or 1 whole, it would be 2, we're still 2 pieces away, but those pieces are bigger. So the fractions are not equivalent. However, let's see another way to see if they are equivalent. And so if we have this 7/9, and we want to test if it is equal to this one, and remember here we're asking, so we could cross multiply, meaning this 14 will multiply the 7 and the 9 will multiply the 12. And so if we do that, we will have 7 times 14. Is this equal to 12 times 9? And so if we carry out those multiplications, 14 times 7 is going to be 7 times 4 is 28. So it's 2, 8, and we carry 2. 7 times 1 is 7, plus 2 is 9. And so we have here 98. Now remember, we're still checking if these two are equal. Now we're going to check for 12 times 9, and 9 times 2 is 18, 8, and we carry 1. 9 times 1 is 9, plus 1, 10. So we get 108, and so we know that these numbers are not equivalent. So the answer for problem 6 is no, they're not equivalent. Now let's see what's going on between these other 2 fractions. And so let's try to figure it out in a different way. Of course, you could always do the cross multiplication. It never fails. But we could do other things. So for example, this fraction, 21/49, is divisible by, let's say 7. Both numbers are divisible by 7. So we can, well, that's actually very bad notation. 21 divided by 7, and 49 could also be divided by 7. And that will give us 3 divided by 7. Now let's see how we can reduce this fraction here. So it's 18 divided by 42, and I know that 18 could be divided by 3, and that is equal to 6. And 42 can be divided by 3. If you're not sure, you could carry out the division. So we have 42 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. We subtract, we get a 1. We drop the next number, which is a 2. Now 3 goes into 12 4 times. 4 times 3 is 12. We subtract, and that is equal to 0. So 42 divided by 3 is 14. Now we're almost there. Now can we reduce this one even further? Yes, because both numbers are divisible by 2. So I'm going to erase this. And so we could divide 6 by 2, and we could also divide 14 by 2. And so that will give us 6 divided by 2 is 3, and 14 divided by 2 is 7. So now we have both fractions in reduced form, and as you can see, they're both equal to 3/7. So the answer for question 7 is yes, they are equivalent. Now for problem 8, we have to find the LCM, lowest common multiple, or as we've been calling it in class, the lowest common denominator between the numbers 6, 20, and 30. And so what we're trying to do here is to find the smallest possible number that could be divided by 6, by 20, and by 30. And so this number, we could try to do prime factorization. So 6 is divisible by 3. 6 divided by 3 is 2. 2 is divisible by 2, so 2 divided by 2 is 1. So right here we have prime factorization of 6. Now let's do the same thing for 20. And 20 could be divided by 2, we get 10. Divide by 2, we get 5. And then here we can only divide by 5, and then we get 1. So lastly, the prime factorization of 30 is going to be divide by 2, you get 15. Divide by 5, you get 3. And divide by 3, you get 1. So we get our three prime factorizations. So now let's go ahead and compare them. So the prime factorization of 6 is 3 to the power 1 times 2 to the power 1. The prime factorization of 20 is 2 to the power 2 times 5 to the power 1. And the prime factorization of 30 is 2 to the power 1 times 5 to the power 1 times 3 to the power 1. So now to find our LCD or LCM, we are going to take every different factor. So we have three numbers here that are different, the big numbers. So that is a 2, a 3, and a 5. So we got to account for each of those, and we're going to take the one with the biggest exponent. So in this case, we only have 3 to the first power and 3 to the first power here. So that's what we're going to take, 3. Then we have 2 to the first power, and we have 2 to the second power. So the one with the biggest power is this one. So we're going to take 2 squared. And finally for 5, we just have 5 to the power 1. So we have that. So this will be 3 times 4 times 5. And that will be 3 times 4 is 12. And 12 times 5 is 60. So that's going to be our LCM here. 60. If you think about it, 60 can be divided by 6 and we get 10. 60 could also be divided by 20 and we get 3. And 60 can be divided by 30 and we get 2. Okay, so let's move on to the next problems. And the next one, problem 9, it's actually problem with like fractions, and we say like fractions because they have the same denominator. And so those are pretty easy to deal with, because if we're adding or subtracting, all we need to do is worry about our numerators, the number on top. So in this case, I'm going to first simplify it. So instead of saying plus negative 3/8, I'm just going to say minus 3/8, because you know that a positive and a negative will give you a negative. So we have that. Now we can say, you can think of it as putting it back into a fraction under the same denominator, like this, 5 minus 3, and they're both divided by 8. And so this will be 2 divided by 8. However, we have to simplify our answer. So this will be, I'm going to erase some of my scratch work here. So this is going to be 1 divided by 4. And that will be the final answer. Now for our next problem, we have different denominators. So we have 9 and 7, and 7 is a prime number. So let's just assume that our LCM or LCD is going to be 63, because that is the product of 9 times 7, 63. So we want both of our fractions to have a 63 for the denominator, and so what we're going to do is multiply our first fraction by 7 over 7, because, and remember, we multiply straight across, so 7 times 4 is going to give me 28. And then 9 times 7 is going to give me 63, which I already have it here. Then for my next fraction, which is 6 over 7, I'm going to multiply by 9 over 9. And in this case, again, straight across. So 6 times 9 is 54. And 7 times 9 is 63. So now that we have both of them with the same denominator, we can say that the result will be 28 plus 54. And that's going to be 8 plus 4 is 12, 2 and we carry 1. 5 plus 2 is 7 plus 1, 8. And so that's going to give us 82 divided by 63. And we will leave it like that. Now for our next problem, we're going to subtract, and we have mixed numbers. What I'm going to just choose to do is to turn them into improper. And so the first one is going to be 12 times 10 plus 3 divided by 10. That is my first fraction. My next fraction is going to be 5, the whole number, multiplied by 15 plus 11. And I have a plus here because I have this inside parentheses and I have my negative there, divided by 15. So if we convert those two, we will get something like 123 over 10 minus here 5 times 15. That's going to give us 75 plus 11. That would be 86 over 15. However, here they do not have the same denominator, and the prime factorization of 10 is just 2 times 5. The prime factorization of 15, it is 3 times 5. So then the lowest common denominator, or multiple of 10 and 15, is going to be the product of 2 times 3 times 5. And so that is actually 6 times 5, which is 30. So 30 can be divided by 10 and 15. That's why we use that. So we have 23 over 10. And then here we're going to have 86 over 15. And we want both of them to have the same denominator, which is 30. So the first fraction is going to have to be multiplied by 3 over 3. So 23 over times 3 is going to give me 69, and then the second fraction will be multiplied by 2 over 2. So 86 times 2 is going to be 172. And so now for these two numbers, we know that they're both, well, one is negative, one is positive, so we have to find the difference. So we could do subtraction, 172 minus 69, and that will give us 103. However, we're going to keep the negative sign because 172 has a bigger absolute value. And so that is going to be our answer for problem 11. And this concludes the second video.